Here we are again. Okay, let's do the fourth problem in the sequence of cables under vertical loading conditions. Just concentrate on vertical loading conditions. Let's see, let's change this to the hair. There you go. Okay, once again, the cable AE supports 3 vertical loads, 1 to 3 vertical loads from the point indicated. If point C is 5 below the left support, so this is this part, that's what I'm telling you here. Determine the elevation of the points B and D. By elevation it means this part and this part, and the maximum slope and maximum tension in the cable. Okay, this is similar to the problem that we were discussing before. The first thing is determining the reactions in order to determine some of the tensions in the cables. If this is a scale, which once again you shouldn't be thinking all the time that the drawings are a scale, the maximum tension is going to happen where the maximum angle is between this, with the horizontal all the time, and between that. Whatever the maximum angle is going to be the maximum slope, and obviously that is going to be here if this is a scale. But we can determine that later. For that, first we need to calculate. In order for calculating even the angles, we need to calculate how much is the sag of the cables at the different elevations that the problem is asking you to do. So first let's try to calculate the reaction. So I can do the same analog process that we did before. If I do moment at B, I don't know how much is this, so I'm not going to be able to calculate the reactions, but remember you have here AX and AY and EX and EY, and by now you should already know that everything horizontally should be the same. So, but if I do here, yeah, I'm going to get two equations in terms of AY, AX, but I don't know this side. But if I do moment here, and I select the left side, and I can do that, for example, this, only moment at C, selecting only this part, the left side of that, I can do it because I can say negative AX multiplied by this height, and this height is given, it's provided, it's 5 feet. So by 5 minus, this is plus AX minus AY multiplied by this distance, and this distance is 30. And then you have this one plus 10 multiplied by 10. 10 multiplied by 6. I mean 10 is the load, 6 is the load, 10 is the distance. 10 multiplied by 6. 10 multiplied by 6 equals 0. From here I can calculate AX in terms of AY. Let me put it like equation like that. 5AX minus 30 AY plus 60 equals 0. And I'm going to call that equation 1. And then I can take the whole thing because I have every single distance that I need. So I'm going to do summation of moments at E, using everything from here to here. And then you're going to start by saying AX negative multiplied by 20, AX horizontal multiplied by 20, minus AY multiplied by this distance, and this distance is 20, 30, 60. Now this one comes here, is 6 multiplied as positive 6 multiplied by this distance, so 30, 40. And then I have this 12 multiplied by 30, and then I have this 4 multiplied by 15 equals 0. If you combine these two equations, this and this, you can get ax equal 18 and ay equals 5 cubed, which by the way is going to be the same ax. Okay, good. Now, if I knew for sure, but I have to know it, if I knew for sure that the maximum value, the maximum angle is this one, I can immediately basically finish the problem. But I don't want to work in that way because I don't know. So let's calculate the summation of forces in y equals 0. And then I'm going to have this ay, which is 5, minus 6, minus 12, minus 4, plus ay equals 0. And then I can calculate ay, and ay is 17. Okay, only with these values. I already know this tension and that tension. Why? Because this tension here is going to be, this is the square root of this square plus this square. That's it. And I know this angle also, this angle that I call alpha 1 over there. If I want to know alpha 1, I can do it in terms of geometry, but I can do it also in terms of the force. Remember this force here, TDE, is based on these two, so I can say TDE is the square root of 17 squared plus 18 squared, so TDE is 24.76 kip. But at the same time, if I calculate the direction of this one, I could calculate that angle by saying alpha 1 is the inverse tangent of the vertical component, 17, divided by 18. So alpha 1 is going to be 43.36 degrees. And I can do that. If I know the distance, the 15, and I know the angle, I can calculate the height if I want to. Now, because now you have this triangle. And this is YD, which is one of the unknowns. And this distance is 15. And this angle is alpha 1. So I can calculate, and I say tangent alpha 1 is YD divided by 15. So YD is going to be 15 multiplied by tangent of 43.36. Sorry, 43.36. And YD is equal to, if it looks like I'm solving this live, it is. I don't have the backup, but it doesn't matter. I like to do it like that. And if I have any error, I will let you know later. But I don't think there is any error here. Tangent of this multiplied by 15, and that will be 14.16. That YD 14.16. 14.16. What units are we working here? Feet. So this distance here is 14.16, and this is one of the unknowns that the problem is asking us to do. Now, another thing that I need to calculate is this YB. How do you calculate that YB? Well, you can do summation of moments in this part to this side if you want to. Summation of moments at B equals 0 using this side. Then I will have AY, negative AY multiplied by 20 in this direction, of course. Now plus AX multiplied by YB has to be 0. Remember, we're doing moment only here, up applying moment here. The 6 skip doesn't produce any moment because I'm taking the moment there. So it's just AX times this vertical distance, which is YB, and AY times this horizontal distance, which is 20. And AX from our previous calculations, that was 5 and that was 18. So if you solve for YB, then YB is going to be equals to 100 divided by 18, 5.55, or 5.55 periodic fit YB. So what is the problem asking? I got lost here. The problem is asking the elevation of the points B and D. We already got it. The reactions, it's not asking us, but we needed to. And the maximum tension in the cable. Well, the maximum tension is whatever the maximum reaction is. Now the maximum angle is. Now we can even check it if you want to. What is this angle alpha 4? Alpha 4 is inverse tangent of YB, 5.55 divided by 20. Alpha 4 is something, which I don't know what is that something, but we will know soon. 15.52 degrees, definitely not the biggest one. Now we need to know this alpha 3. Okay, let's do that triangle over there, alpha 3. So what I have this is this, alpha 3 is here. The horizontal distance, I know it because it's 10, and also I know YB, and this angle is the same angle as this one, alpha 3, so I can know also this distance here. Why? Because the total distance is YB and this distance is 5, is provided, so this is going to be 0.55, that's going to be that, and alpha 3 is going to be inverse tangent of 0.55 divided by 10. Inverse tangent is 3.17 degree. Now we need one more. We already calculated this before. We need one more here. This angle here, well, that angle, we need this height. Can we calculate that height? Well, I know that this is 12, this part, so it's good. I know this is also required, is 5 here. This is 20, and this is YB. So this distance here is going to be 20 minus YB, and YD, and we calculated that YD before as being 14.16. So this is going to be 20 minus 14.16. So that distance is 5.84. 5.84 is this, and this is 5. So for the last triangle, we have something like this. We have this is 12. This is 12. This is 12, which is this, and this is 5, and this is 5.84, and this is alpha 2. So alpha 2 is going to be the inverse tangent of 10.84 divided by 12. 10.84 divided by 12, inverse tangent is 42.09 degrees. And we calculated previously alpha 1 and in our sheet of paper, alpha 1 was here. I was 43.36. So this is the maximum slope, and this is where the maximum tension is going to happen because it's the maximum slope, and this corresponds to TDE, which is this one here. So the maximum happens here where the angle is maximum, and the maximum slope is that one over there. One other thing we can calculate here. Oh, we need to calculate the tension here, the tension here, the tension here. But you have everything else, you can do it. If I want this tension, I can say that this is the square root of this square plus this square. There you go, you have that tension. Oh, look at that, just in time. Alarm, alarm, they are kicking me out of the room. So I have to evacuate, guys. I think this is just a test, but just in case, stay safe, see you later. Bye.